Alright, so welcome to my channel. I don't know how you got here, but I do hope that you'll stay until the end because in this particular video we are going to actually work on a project of mine, which is a studio unit here in the Philippines. A very typical studio unit, very small, not very spacious, but very yeah. So to start off, we're gonna make some scribbles here. For me, I really don't like making perfect drawings right off the bat because I feel like, that's just making room for, or that leaves room for improvement. And if you don't have room for improvement, then you tend to miss things that you would have figured out later on that might have been like a better idea. Another thing is we won't be able to get an as-built plan for now on this site. An as-built plan is when you work on a project that already has an existing space, an existing building. And what happens is, since we can't really move certain structural members or things are already fixed in place, we would make an as-built plan, which is basically what has already been built, like getting exact dimensions and making exact plans of what already has been built. The reason we can't get that at this moment is because the building that this studio unit is in is not yet finished. So it's a pre-selling unit, and what we do have to work with are some pictures, some videos, and the property owners own plans that they give out to customers, which aren't really exactly precise. They're kind of like they're kind of the unit at its best. But anyway, so actually I'm gonna try to just make rough drawings based on the information that I've already seen and been given. So anyway, we're gonna start by making very, very rough drawing. You don't have to be perfect right off the bat, because when you're perfect right off the bat, then what's the meaning of life? You don't have anything to strive for. Which is why I really do believe that there's nothing wrong with making scribbles, as long as you can interpret them. And what's even better is if you're good enough to make scribbles that other people can interpret. That's like when you see an artwork that just for some reason it makes sense to you, even though it doesn't make sense to most people that aren't really feeling that same emotion. So that's the same way I feel about when I make drawings. Sorry. I'm not gonna input it into the computer yet, because I usually prefer that we do sketches first, because people that also just go right into the computer right away tend to finalize everything on the moment, which is bad practice. You should always try to, it's always better to make mistakes in the beginning than it is to make it later on, or realize you made it later on. And when you make mistakes in the beginning that you see right away because you didn't make it fine right away, it leaves a lot of room to make better tweaks, better adjustments. So anyway, I'm sorry about that long intro, but let's go ahead and keep going with this. So from the information I know right now, this is about a 20 square meter unit. And we have this here, and we have the door opens this way. The main door opens this way. And the restroom door, I believe it opens this way. Let me just check that one moment. So we want to be sure. So this actually opens the other way, and it's actually way over here. Okay. So it's like these details, see, since I didn't make that into a final thing, because I wasn't sure. It gave me some time to actually, think about it, be sure, is this really the spot? Okay, so actually, it's right here. So in the plans that the developers give us, they give us different ideas of where it is. but here we have it here. That's why I also believe you should always get do as-built drawings, even when you're provided with your plans by the developer or what have you. You should still always, you know, make the extra effort to do it yourself. If you can't do it yourself, then ask for some help, ask for some, or maybe hire an assistant if you can. Unfortunately, I cannot, so I'll work with what I have. It's a bit longer, I believe. Yeah, let's make it there. And there's actually a beam over here, so we're gonna go ahead and we want to take note of that because there's nothing we can do about a beam. I mean, not a beam, sorry. There's a column here. Why do I keep getting those confused lately? And we have a window here. So we have a window, and we have another window here above the counter that's already been set up. Okay. So this is our unit as of right now. Let's go ahead and make it a bit darker so you can see it better. So we're just gonna make it super duper rough. Remember, no shame in just, you know, there's no shame in scribbling. I really never enjoyed it either, in being in studying architecture, and then they just expect you to make something perfect right away. Perfection is, I don't know, it's a scary thing to think about. I always enjoy the imperfections of life because that's what makes the world real. Okay. So now we have this idea of what's going on here. Okay, we're not really going to focus on the comfort room that much, so I'm just going to shade this out for us. And we're mostly going to focus in this area. So what we want to do is we want to make a layout of the idea we have. So right now I'm visualizing we're going to have a partition here. Okay. And this is actually where the ref is going to be. So I'm not quite sure how big the ref is. Now don't be afraid that, you know, this doesn't look like it's the scale, right? Because it's not the scale, and I'm not trying to make it the scale. What I'm trying to do is give myself an idea of how I'm going to proceed with this project. Okay? And we always have to remember our own limitations when we work on things. Next thing here on this side is actually going to be a washer. So the way this the developer has laid out the floor plan of the unit is, this is meant to be for a washing unit. Excuse me. So that thing is already, this space is already occupied by a washing unit. So most likely we're going to see better results when we start doing elevations. Try to always work in, you know, you're going to imagine things in 3D, but try to work in plans and elevations and sections before you actually do it in 3D. That way you have a better idea. So we're gonna kind of like try to make this evened out here. And maybe we can put a shelf here, we can put that there. And since we have this column way over here, we're gonna kind of put a cabinet here to even it out. And maybe we'll make another partition here. So we'll have a partition here. Okay. And then we have this here. And we're going to make another partition on this end. So this length is going to be for the door. Or not really a door, it can just be like a pathway. But we want to have like some sort of level of privacy here. Let's go ahead and just shade it really rough. Okay, there. So we have that, we have that, we have that. We, from what I've been told about the client, they really have a lot of things that they want to, they don't want it scattered around. So we're gonna try to make it, we're gonna try to give them as much storage as we can, sorry. I kind of want this to be level, but we're gonna have to see what happens as when we're able to actually do an actual site visit and do a real make an as-built plan, which I'll probably have you guys tag along with me while we do that. Let me just go ahead and back out here. I'm looking at the video. Okay, So the thing about this side here is you have to when you make, even if you're just like doing these scratch drawings, you should always have an idea of what's going on everywhere. Now I remember that it was mentioned there is an air conditioning unit on this wall. I believe it would have to be on this wall. Sometimes we have to use kind of have to break down the information as we're working along, because I don't have all the information, so I'm just gonna have to break it down. The reason I would assume that would be this wall is because we have a window here in the kitchen, which would mean that this wall must be somewhere along the exterior. And the video doesn't really show that well, so I'm not quite confident, but I do have my suspicion, at least, that that's the side it's going to be on. And that's based from my logical thinking. So I'm going to go ahead and assume that, yeah, this is actually where it is, somewhere around here. So that means our cabinet, our supposed cabinet in this area, is going to have to be modified a bit more, since we can't use it the way that we were hoping to use it. We also have to take note of a lot of the things that the client has expressed a desire for in their unit. Even though we like, as an architect, even though I like to design things that I personally like, it's kind of there are kind of decisions that we have to take into effect when it comes to what the client wants, because at the end of the day, they're still the client. Now, as long as the client isn't asking me to, simply copy paste something else, then I don't really have much of a problem with that. And as long as they allow me to have the freedom to, like, if they give me input that they want to be put into their unit, I have the freedom to at least express it in the way that my personal methods would work out. There will be times, though, you'll meet clients that they don't really care about your opinion. And at the end of the day, it kind of depends on the kind of architect that you want to be. Hiring an architect is kind of like choosing where you want to eat. Like, you can just have like a generic fast food. You can go to some place like McDonald's, Jollibee, something like that. Or you can go someplace where, the chef is, making something special. Like, they actually do something where they think that this is their style, this is how they prepare food, this is and yeah, that's how you should hire an architect. You shouldn't look at it as the architect just does whatever you want. No, when you look for an architect, you always have to keep in mind that each architect has their own style. If you really just want the architect that's gonna do whatever you want and just sign your documents, you can expect that your project probably won't feel as homey as you'd like, or it won't feel as personal to people. And I've experienced that myself. A lot of people would say like, oh, that's so beautiful, blah blah blah, something like that. But it doesn't have that feeling, that it doesn't have an emotion to it, because it's so cold when you go inside, because there's no artistry behind it. It's just simply copy and paste. But don't get me wrong, there are also architects that are just... Anyway, let's get off that tangent. Okay. So yeah, we're making this just super rough, guys. So if you're an architect and you're not good at drawing, don't worry. It's not a necessity. So we're gonna have the bed here. Now, based on the developer's plan, this is somewhere, this here to the comfort room or the toilet and bath. This is somewhere around 4 meters. So we're not quite sure yet. We don't quite know how many meters or what's the exact measurement of it, but we can say that it's roughly somewhere more or less 4 meters. And then here in our kitchen area, we can say that it's roughly more or less 2 meters. So right off the bat, you can kind of tell how small this unit is. But it's a very typical unit for here in the Philippines. if you're a foreigner, these are actually quite affordable, but uh, when you're a local, yeah. Anyway, back to what I was doing here, and let's go ahead and give this width. So this is all based on the developer's drawing. It seems like it would be somewhere around 1.8 meters, I'd say. So, and the overall width ran out of paper space. So this is not the scale, guys. So don't don't judge me. The overall width is somewhere around 3.5. So that's 6 meters. 6 times 3 is 18.5. So that's another 3 square meters, 21 square meters. So this unit is actually roughly 20 square meters according to the developer, the salesperson of the developers. So yeah, this is roughly correct, with an additional 1 square meter that we don't know where it came from. But there's a possibility that the unit also has like an angled wall, which we'll eventually find out once we go to the site. Now, given all this information, so we have this column. We can't do anything with it. No matter what, this is going to be here. We can't chip away at it. We can't tear it down. We can't make any more space. And then we also have the opening for the air conditioner, right? So now we know that we cannot do anything with that area, which means that this leaves us this space for the bed. As I was saying earlier, the client has expressed that they want certain things in their unit, which now we're going to have to figure out how we're going to put it in here. To begin with, usually a window type AC of this size, I would say it's somewhere between 0.5 to 0.6 meters. So this width here. So that's what space we have to work with there. And if we're going to be, breaking this down the line here, we're going to have to say that this is somewhere, we want to split it right down the middle. So we want 2 meters, 2 meters. Which is perfect for this unit because that means that right here is enough space for, a lengthwise bed, if this is the lengthwise. So if this is the person. Okay. And then we know that this kitchen area right here takes up 1.8 meters. 1.8 minus 3.5 minus 1.8 is 1.7. So if we can probably deduce that this is somewhere around 1.7 meters wide. Okay, like I said, that's not final. We're not quite sure, but at least we have. Based on the logical thinking of how we're approaching this, we can say that we do have 1.7 meters here. So now you're kind of seeing the Tetris portion of architecture. So 1.7 meters is also enough space for 2 people. So we can have 2 people side by side. Typically, the way you can tell the sizes of beds, we have 0.9 for a single. 0.9 so right here. So 2 times 0.9 is 1.8 meters. This is 1.7. We have enough space for a bed. So we're actually going to make a custom bed for them. We're going to design a custom bed for them. We're not going to make it. I personally don't handle construction anymore. I've been through construction. I just don't enjoy it. I really just enjoy designing mostly. And whenever we approach design, don't think of design as just beauty. Design is not beauty. The word design, when we use the word design, think of it as problem solving. We are solving a problem that the client needs help with. Because when you just think about it as beauty, then what happens is sometimes you don't even end up solving the problem. You make something like really extravagant, but you completely miss the mark, because it doesn't give you a solution to what the client needs. So that's just a little side note for you guys. Just always remember that it's not just 3 points to it. We have beauty is of course one of them, but we also have functionality and structure. Okay, so let's see here. So now we know that that's 1.7. We have a rough idea that that's 1.7. Whew. We're going through a lot of information here, sorry. So 2 people can fit here. Whichever way the head and the feet are going to be, we're going to have to figure that out along the way. But for now, at least we know that is the fact that this is good enough for them. Okay. So this is all just based on the floor plan right now. As we go further, we also have to take into account the details of the height, which you don't see on the floor plan. You just kind of see how the layout is. So even though we do this, we still have to figure out what's going on in the other areas in terms of height, and like if we can actually make anything work by using the height to our advantage. Excuse me, sorry. Now we have this giant column here on the right side. Let's see here. What can we do about this column? And we also have the air conditioning. Now we kind of have to figure out how big this column is because we don't have a drawing. We don't have anything to work with. We don't have a proper plan to work with here. But based on the video, it seems like it's really in there. I'm gonna say that it's somewhere between 600 to 800 also. 600 to 800 deep. I've actually talked to the client about this method where I would just give them sketches. So a bit of a background of why this is the steps we're taking for this project. The client does have a specific timeline that they want to reach. So they hired me in order to start figuring out sketches on how to approach their structure and how to approach their unit, sorry. And we still don't have an idea of the actual measurements. So what happens is now I have to base everything off of what I think from what I can see. And so I've told the client that most likely I'm just going to make a bunch of rough sketches, because if I input this in the computer without having, proper dimensions, then it's just going to be a big no-no. It's just going to give me it's going to be a very stressful project, like a stressful environment for each of us, because we don't know anything about the unit. But in this method, at least the client can have an idea of what we can do with the unit and what we can assume is going on in the unit. So my assumption is that this will be somewhere between 600 to 800, 0.6 to 0.8 meters wide, this length. And I'm also assuming that this portion here is somewhere between 500 to 600. This is just, wishful thinking. So we have this is like the main window right here, somewhere big. Another thing about when you work with floor plans is like you have these kind of instances where the window is not aligned, and that kind of freaks people out sometimes. So you shouldn't be freaked out by that. It's okay that it's not aligned with certain things. And try to always, try not to restrict yourself to always being aligned and stuff. What matters is the how everything meshes together, not how everything is aligned. Okay, with that said, if we take the biggest number plus the biggest number of the AC, we have 1.4 meters, right? So we want to work with the biggest number, that way we have the biggest idea of what's going on. If that's 1.4, so we make 2 minus 1.4, we have 0.6. Okay, sorry, let's fix this a bit there. This is 0.6. I'm actually taking note of everything in millimeters, so maybe you're confused with how I'm taking note of it. But just so you understand, this is 0.6, it's just in millimeters. 0.6 meters. So that means we have enough space for a cabinet, a really small cabinet. We kind of have to figure out which way we want this cabinet to go. So it's not the scale, right? But at least we have an idea that we have a cabinet here, which means this air conditioner is kind of restricted to this zone here. Now we're gonna have to discuss this with the owner if they're okay with this idea, but at least we have an idea of what's going on. Because what happens is when it's constricted here, the air kind of gets absorbed into other areas. Remember that cold air is the absence of heat, okay? So if we have hot objects around the air conditioner, then it's most likely going to just absorb the heat into it, or the heat is gonna overpower the air conditioner, which is something we don't want. So if they have a strong air conditioner, then that will be fine. And another thing is, since the air conditioner will be blocked off from this area, most likely it's only this area that will be able to get cooled down, unless they put an electric fan here. With that said, we don't really need this cabinet here, but we have to really discuss it with the client. Also, with that said, is we're not quite certain where the location of this AC is. We're still just assuming that it's like right next to the column. Now, another thing that the client has expressed is that they wish to have things that they'll have guests over often, so they want to have extra beds. But as you can see, what we have here, that's just not how it works. So I kind of have to figure out a way to make an extra bed pop out of nowhere. And if we only have 2 meters here and we have 3.5 there, the extra bed is somewhere here, you know. It's just going to be somewhere on this side. And this side, we're not going to be able to put an extra bed. Most likely this will be where our TV console will be. And most likely a very small dining area. Very small. Okay. Another thing about chairs, another thing about space is we have chairs here, so we can fit 3 people here, right? Don't worry if the chair is in the way here. So chairs can get tucked under the table. So we can always tuck in chairs under the table, and it makes up more space. But we kind of do this to represent that there's space for a chair here. And we also want to have the idea that this isn't fixed. So how am I certain that this is enough space for 3 chairs? Well, actually, a small table, we can get a small table at around 0.8 by 0.8. Okay, and then these chairs right here can be somewhere around 400 by 400, 0.4 by 0.4. Okay, so we have 3 of those. So if this is 0.8 by 0.8, we have this at 0.8, and we know that this area is somewhere around 2 meters already. We know that we have a space of 1.2 meters left. And let's say we take up 3 here from this partition that we made here. Let's say that this is somewhere around 3.3 meters. We have 0.9, and that's kind of how I have the idea that 2 chairs that are 0.4 can fit under here. Okay, so it's a really tight space. We have to figure out how to make it work the best we can. And another thing we're not really taking into consideration here is the thickness of this partition. Most partitions are 4 inches, or roughly 0.1 meters, 100 millimeters. So that takes away another 1, so it's exactly 0.8. We can also make the table smaller, actually. So it can be 0.8 by 0.8, or it can be 0.7 by 0.7. And that's still enough space for a decent sized table for 2 people or 3 people. 4 people, that's a stretch. Okay, so now we have an idea of what's going on there. Here we're gonna have a pull-out cabinet. So it will be kind of like shelves that will just pull out of there next to the fridge. This space right here is most likely somewhere around 0.9 meters. Door, probably 1 meter. But obviously we have 1.8 here, so this is obviously not correct. There. So it's most likely 900 also. Okay. So now we're still bamboozled here on this side. We have to make a way. So we took away another 0.3 here. And if ever, our space right here is going to be somewhere around 1.6. If we just had like the complete interior space, 1.6. 1,600 millimeters. Which is still enough space for 2 persons if we make a custom sized bed. But they've also expressed that they want more cabinets for storage, which is why I'm kind of taking up this space to make more cabinetry space. And if they're going to have more storage, then that means we have to take up this space as well, and we have to take up at least another 400 on this side. Okay. And furthermore, that leaves us with very little space left. So we have 900 minus 0.4 plus 0.9 is 1.3. 3.5 minus 1.3 is 2.2. Whew, 2.2. So that means this space right here is the exact amount of space needed for one bed. One bed for 2 persons. Okay. Now we have to figure out how we're going to do this. So first thing we're going to work on right now is we're going to go ahead and work on the kitchen first. And we'll figure out the living, the dining, which is actually just a combined living and a combination with the living area, and the bedroom area. Okay, so I kind of already have my concepts going in my head. Like, this whole unit is just going to be one giant, or one tiny transformer. But we still have to put that application into the project. Let's see here. 0.8, 0.9, 3.5. So what we have here is, this was going to be, we're considering this to be somewhere around 600, correct? So this will be aligned, hopefully. And then we said earlier that we have 1.7 here. So 3.5 minus 1.7 is 1.2. So that means that we have another 600 here. Okay, correct. Or sorry, wait, that's incorrect. 1.7 plus 600 is 2.3. 2.3. That means we have 0.9. Sorry, we have 900 here. So 900. So that's correct. Okay, so that means there's kind of an over here in the wall, which is correct also, because the typical depth of a kitchen countertop is around 600. Okay. All right, so now we have our idea of what this unit looks like. We have space 900 here, but we can actually shrink this down to 800 to make more space for the bedroom, for the bed. In fact, we're gonna go ahead and let's go ahead and make this 700. Let's just make more space for the bed area. 700, okay, and that makes this one 1,900 because we added another 2. So this is actually enough space. If you're wondering, a typical person can be somewhere between 0.6 to 0.8 meters wide. That's just a very standard typical person. When we work with architecture, we typically work with measurements in architecture. We basically use this science of anthropometrics and proxemics, and all of those are just all based on standard sizes. And when you have a firm grasp of all those ideas, then you're able to actually just kind of manipulate things into a way that will work for your design. we're not actually gonna make the bed 1.9 meters wide. It's just bad termination when, you know, like the bed is completely aligned here. So we're gonna kind of have like an extra 4 inches hanging out on the edge of the bed here. And then for here, since this is just a closet, we don't, depending on the way we're gonna make it face, it's okay that, you know, it's directly flush with the partition, but we still have to work out what's going on here. But if you ask me, there's a very high chance that this will just be a desk with an overhead cabinet, which means that we have to figure out where we're going to put the clothes of this our client. For the bed, we'll have some, what I'm thinking is the cushion can be removed, and we'll have like extra blankets on this side, and then here we'll have pull out drawers underneath the bed, right? Pull out drawers underneath the bed, because they've expressed that they don't really want to share a room with their guests, so they really want the guests to have their own space out here. Whether or not they're going to have a door, we'll go ahead and discuss that with the client eventually. And then, so that leaves this here, right? We're gonna have, I'm gonna have to design a bed that's going to come out. Now I know what you're thinking, you know, there are those beds that, you know, just fall to the ground, but as much as possible, I don't want to go that route, because that's kind of scary for me. If you keep, sorry, excuse me. If you keep designing things just because they're convenient, then there's no point of, you know, continuing being an architect. You might as well just be a contractor that, you know, provides, or a supplier even, that just provides the same old typical thing. When you're provided with this kind of a project, you might as well try to put in the extra mile and make an effort to design something that's a bit more safe, a bit more friendly. And that's what I hope to achieve here. If ever, it's also possible though, the bed can be here. This is still enough space for 2 persons, just barely. Just barely. But we have this at 0.9, right? We can still take a bit of, we can like add a partition here just to make it a bit, you know, closed off, make this into 700 both sides. It's possible. Is it a good idea? We're not quite sure yet, but we'll figure it out as we go along. The first thing we're going to work on right now though is the kitchen. Okay, so I'm going to go ahead and tear this page off, because when I work on things, I want to have a visual representation of the area I'm also working on. So like I said, we're just gonna kind of make completely rough drawings, and, you know, hope that everything works out as we go along. So I'm gonna turn the plan around, and we're gonna kind of we're gonna try to make a view of this angle right here. This right here. So this is our viewpoint. This is also the beauty of just making scribbles, like. You know, I still take these drawings, you know, seriously, but at least, you know, to me, it's more, you know, it's more of my tool than it is for other people. Okay, so with that said, we have that view. I'll probably teach you guys how to do a proper perspective in another time, but not this time. This time we're just gonna make some quick sketches for us. Okay, like I said, we don't really know how high this thing is, so we're just going to kind of assume that this is somewhere around 2.5 meters, right? Now, when we're looking at this view right here, our view is kind of obstructed with this wall, which kind of makes it look like a flat surface. So it's not really a flat surface, but it looks like a flat surface. So we're kind of just going to assume that it's somewhere around there. Okay. And we know that the door is 0.9, we know that this is 0.9, and I said that we're going to assume that the height is somewhere around 2.2 2.5. Let me just review this one more time. Oh no. Well, if we're basing it on the information we're given, the height of this is actually the same height, almost the same height as the door, which is kind of bad news for us. Like there's just, so that makes it around 2.2 meters high. So 0.9, 0.9, 0.9. Let's say it's about that high. So this is our reference right here, right down there. Okay, we have our wall that's just really high. And when we're gonna make a bunch of drawings for this project, so don't think that this is it. This is not gonna be the final. This is not the final product. We always just make a bunch of drawings. So unfortunately, I don't like using a lot of paper because I like to save the trees, but it's part of the job. But of course, you can do it in the computer right away, but you're missing out on the joys of being an architect if you're just always going to be on the computer. Okay, so a mistake that I've made here is kind of don't have a space on this end. We don't have enough space to see everything that's going on. So the trick is we're just kind of, since I just drew it in lightly, we're going to kind of cut this in half. There we go. And we're going to make this 0.9 right there. 0.9 right there. That means that the height is going to be different. So 0.9, 0.9, 0.9. There. Okay. Right. This is our new thing right there. So when we're doing with the pencil, of course, we can just erase. We don't have to make perfect erasures, but we just have to get rid of the lines that we're not using anymore. So nothing here is to scale. Okay. And for these instances, I do have a brush because whenever I blow, spit comes out with it. All right, so we have this line here. Okay, we have a line here, and we have a separation here. We have a door here. Okay, and let's go ahead and stretch this out. So first thing we're gonna do is we're going to just make a rough idea of where everything is, or the heights of everything. So as you saw earlier, this is kind of our reference as 0.9. So you're gonna kind of use your eye, 0.9, 0.9, or sorry, 0.9, 0.9, and then this is somewhere around 0.2. But we have to kind of fix this door. Okay. So we have a door. We can use our eraser again to kind of get rid of the excess lines. Okay, we have our door. A countertop is somewhere between 0.85 to 0.9, so we're going to kind of go somewhere midway around the door. So this is our countertop right here, somewhere around that location. And we're going to kind of try to imagine how this is vanishing into the vast nowhere. So we know that this is somewhere around 0.9 also, so we're going to have to divide it into 3. And that will kind of give us our countertop depth, which is right there. That's about 0.6 right there. That sweet spot right there. We're gonna use the top and the bottom lines to kind of give us an idea of how the perspective will work here. Okay, perspective. Okay, and that's that. Now don't forget there's actually a washer in this part, so that's not exactly where it's gonna end up. Okay. Now that we figured out the heights somewhat, so we know that this is somewhere around 0.6. Now we're gonna try to figure out the depths. Now the thing about this is it's gonna be really sharp. So we're going to kind of assume that the size of the washer is 0.6 also. So we're going to make a line here. And we're going to assume that that counter was somewhere around 0.8, the existing counter. In a 2 points perspective, we're going to kind of have, we're going to end up with lines that are just flat. So this is actually a 2 point perspective. Okay, so that means that somewhere around this area, oops, somewhere around here, this is where the window will be. So the window most likely has a height somewhere around here as well, as high as the door. So around 2.1. And the height of that window is probably somewhere around, according to that drawing, or according to the video that was given to me, somewhere around 0.6. So how do we assume that this is 0.6? Well, we kind of divide this into 3. And there, 0.6. Okay. So now we have a window that's in the way of a lot of our things. This window right here kind of causes a lot of problems. First problem we have right here, so way for that washer. So no matter what, this is a washer. Then next thing we have is we have this window. So let's say that since we have this window here, we're going to make an overhead cabinet in this portion here. Based on the pictures we also have, we have a sink here which takes up about half that space. Okay, and the sink's head is somewhere around this height. So that means we can put an extra shelf around here, and we're going to add another shelf around here. Okay, so this is actually a very low shelf, but hopefully it'll be enough space to work with a lot of things. And we're going to extend that shelf all the way till the end, right? Bam, all the way to the end. The problem with that is this washer is here, and the washer kind of has to be uncovered because the opening of the washer is something like that. So it goes up, right? So we probably won't be able to use up all that space, but we can use this top space up here. But like I said, we have an overhead cabinet. So let's go ahead and work with what we've got here. For the overhead cabinet, we want overhead cabinets can be somewhere between 0.3 to 0.4 in depth. So if we know that this is 0.6, we can just cut that in half, go up, project upward, and so my line right there is incorrect. We're gonna adjust that line to right around there. Bam. Okay, get rid of that. And we don't want one thing you don't want to do is you don't want the cabinets to always be like completely up to the ceiling. You want to have like space because it kind of makes it look really cramped. So in order to avoid that, we have like this fascia at the top. Fascia is basically just a board that covers an open unused space. Oh shoot, sorry, right here. Okay, so actually you can tell that we did something wrong here because in this perspective, this should line up with that corner. So bam, we're gonna adjust that right now. Okay. Remember, this isn't to scale, guys, so you don't have to worry about being super perfect. So we have what we call a fascia right up here on the top. Okay. Bam, bam. Okay. If we're assuming that the washer is somewhere between 0.6 meters wide, we're gonna have to just split it right down the center. Okay. Bam. Okay. Now I'm gonna add another fascia here, around 100 meter, 0.1 meters here. right in front of the window. Okay, sorry. So remember, the fascia is just we use the fascia to kind of make proper terminations, because what happens is when you don't have a proper termination, it kind of makes the structure just looks messy in a way. It's kind of the same principle with baseboards. The reason we have baseboards is because we don't want to see the imperfection of the floor to the ceiling. Like when we see the ceiling come down to the flooring is not completely flat. So the best way to make it look flat is by installing a baseboard. There's a practice here in the Philippines where they actually paint the baseboard, and I hate that practice because they're just completely destroying the whole purpose of having a baseboard. Because when you paint the baseboard, you're not concealing the imperfection. And that's why earlier I was saying that if you try to make a drawing perfect on the first go, that's what you're basically trying to do. You're just trying to conceal the imperfection. But I like to know that, like, when I make a drawing, and when I see other people make drawings, I like seeing the imperfections first. Because when you see the imperfection, that's when you get an idea of how difficult something truly is, and how that's what makes it even more special. You know what I mean? So anyway, yeah. So there. With that, so like I said, we're gonna kind of put a shelf here, right below as well, below the overhead. And to make the termination even better, we're gonna kind of make it a bit over, like not exactly flush to the cabinet, the overhead cabinet. Yeah, something like that. Okay, and with that said, we kind of have this space made here, right? Okay, with that, we kind of want to do the same thing on the top. So we want it to kind of extend a bit. So this is a really sharp angle, but we're gonna make it extend just ever so slightly. Yeah, that way we have like this. We have this kind of natural division going on here. There. Okay, and then here, so we're gonna kind of like make that flush there. Here in front of the window, we're gonna go ahead and make curtains. Okay. Okay. So what we did is, bam, and we're gonna make it a bit of extra. What we did is we kind of tried to make the terminations of the overhead cabinet a bit more interesting to look at. Okay. Okay, so there we have that. Now we have the problem with the washer. So as I said earlier, I was hoping to put a shelf here as well. But we have to worry about the washer now, because the washer has to open upward. But if ever this was going to be the shelf right there. Perhaps there's a way that we can not have the washer. No, we need the washer. let's go ahead and make some more details here first. Okay, so we're not really utilizing the full extent of this paper, but kind of want this to be as flat as possible, so that's why this is kind of like that. Whoa, come on. Okay. Sink is just gonna be the sink. It's gonna be, you know, just here. It's the sink. Nothing we can do about the sink. Flat here. The end of the sink is right around here. What we're gonna do is, so another thing is the end of the window is somewhere over here. Right here, we're gonna put a partition where the fridge is gonna be. So you're not really gonna see it. There's a lot of things that's gonna be covered up all of a sudden. So we're gonna we're gonna confine the space of the sink and the countertop. Okay. And that's just gonna be up to here though. So we're gonna go up, and at the top of this, right here, so we're gonna have the refrigerator in this area right here. A typical refrigerator is somewhere between 1.5 to 1.8. If you have a really big refrigerator, it can be 2 meters and above. But most refrigerators aren't as big as most people think they are. So yeah, that's gonna end up being covered up here, which means that we're gonna have to go ahead and pull out our handy eraser again and go ahead and erase that. Okay. Right, and this is it's kind of taking a bit of shape, but we're struggling so much with the amount of space that we're left to work with here. So the refrigerator, like I said, is somewhere between 1.5 to 1.8. Let's say it's around 1.5. We have here 0.9, 0.9, so we gotta go a bit lower. Go here, go up there, and then we have to project it out here. We have to assume that it's somewhere around this height. All right. So we know that this countertop here is 0.9, and we're gonna say that the height of the sink faucet is somewhere around 0.25. So then we're gonna have to add another 0.5 here, 0.5 to 0.3 perhaps. I'm sorry, not 0.5, 0.05. But let's just add another 0.1 to make it a flat 0.45. Okay, which makes this at, if we're going to assume that the window height somewhere around 1.6. So that makes the refrigerator right below the window. And that makes the height of this kind of low also. So we're just, the more we go on here, we're just making less and less space for our users, sadly. Yeah, so what we can do actually is we can extend this here and make them into more shelves. Oops, sorry. What happened? This is supposed to go lower, actually, sorry. Lower. This is the fascia here. We have that. Okay. So we have a washer that opens up this way. We have a sink that's over here. We have a refrigerator that's over here, taking up a lot of space. We have a, let's say it has a freezer as well. And this one is incorrect, sorry. It's supposed to go down more. This is the back actually. I should have erased that earlier so it makes more sense. Right around there. Right. Okay. Right around there. Have a washer here. Okay. So this is gonna be our starting point for our kitchen. So we have a lot to work with. Bam. But at least we have a better idea now of what it will look like as 3D. So we're gonna, as the project keeps going, we're gonna figure out more and more what we're going to do here. But right now, we've come to a bit of a a block in the path, a wall in the path, I'm sorry. And I'm gonna have to do some brainstorming, but another important thing about designing is if you don't have the solution at the moment, then you shouldn't force it out. When you rush things, things just tend up to get worse in my experience. So we're gonna end this video here. I hope you enjoyed watching. I know it's been a bit of a confusing ride, but you know, this is kind of a more traditional way of how to approach architecture. We're just doing it all rough and we're just having fun with it. But anyway, until next time guys, I hope you always take care. I hope we can always better ourselves, and bye-bye.